Yo everyone, this is page 429, and we are going to be talking about some applications of the chord diameter theorem, or maybe it's diameter chord theorem. But anyway, if there is a diameter drawn and it happens to actually perpendicularly cross any other chord of the circle, like some other random chord, whatever, if there's a perpendicular intersection, that chord is going to be bisected by the diameter. So let's actually kind of like demonstrate that. And what I'm going to draw is not going to be perfect for what you're going to like able to match. Follow the directions, create your own, and then think about how we parallel each other. Good math word, by the way. So in this one, use circle T, so here it is, to draw two congruent chords that are not parallel to each other and do not pass through the center of the circle. I think I'm going to use the measuring device. So I'm going to you should have a ruler out, right? That's probably the best way to do this. And I'm going to draw a line through from like one side of the circle, not through, but touching one side of the circle and touching the other. Let's go something like this. Now, the nice thing about my lines is I can actually measure them on the screen. So I'm going to go in exactly 1 inch. Yeah, perfect. Okay, so there's one of my chords. It's exactly 1 inch, and it is going from this part of the circle to the other. Now I have to draw a second chord that is the same distance as this one. So kind of like with just measuring with your ruler device. You need a ruler, by the way. Surprise, surprise. I'm going to draw another one. I think I'm going to draw one like this. I'm on the circle. The nice thing is I can finesse it to get it to where it needs to go. About like that. Yeah. And measure here. Uh-oh. Don't do this to me. Okay, I want to be on the circle as best as I can. I got 1 inch there, 1 inch on the other side. So those two chords are the same. All right, now it says construct the perpendicular bisector of each chord. And so that's what I'm going to do next. I'm going to go ahead and, well, let me get rid of you. Get rid of this one right here. There we go. I'm going to go ahead and draw the perpendicular bisector. The way to do that without using a compass is actually to trace it. And so if you get some tracing paper and you trace that chord and then you fold the tracing paper in half so that one end of the chord lines up on the other, that's your perpendicular bisector, the crease on the paper. For me, there's no nice tool with this app that I'm using, so I'm going to go ahead and eyeball it, but I do know something that I can do. Maybe I can bring my measuring device out and I can measure along this measurement to 1/2 inch. Okay, so that's going to be my measurement to the middle. I'm going to do that down here too, measuring 1/2 inch. About right there. Okay, so really just trying to set up the fact that I've got a chord right here that's cut in half and another one cut in half. Now, the thing is, after I construct my perpendicular bisector, knowing a little bit about where it's going to go, I'm going to draw in the perpendicular bisector like this. Let's make it blue. I can go from there. Well, that's a nice large line. Okay, a little bit off. Make the adjustment. There's my perpendicular bisector of chord number 1, the blue line. Now my second one, my perpendicular bisector of the chord on this, the perpendicular bisector of this chord right here, I'm going to go like this. I'm going to go from here through, we'll extend it. Now the goal, they should cross in the middle. And I'm going to get my measuring device out and I'm going to measure the distance from the center of this chord to the actual center of the circle. Because that's the next part. Choose a construction tool and compare the distance each chord is from the center point of the circle. If you use a compass, you just set your compass points, pencil and metal part or center part, and just let your compass be your measuring device. It's the original measurer. Okay. For us, because we have the technology, I'm going to go ahead and measure from, let's go with black, from here to the middle, and I get a measurement that is approximately 0.26 inches. Nice of the computer to do that for us. And then right here, 0.26, 0.25. I'm off by a little bit, but the key thing that I want to say is the distance between these chords to the center of the circle is going to be the same. Take a look. Zoom it in. Each chord is the same distance from the center. Sketch that right here. Each, as in every congruent chord, is the same distance to the circle's center. What I drew, different from yours. You don't have my handiwork directly in front of you. You should be creating your own, and think of intelligently about how you're creating it. Each and every chord that is congruent is going to be the same distance to the circle center. Thank you for watching this video. This is page 429. I will see you in the next one on page 430. We are marching forward. You are awesome. Thank you for being here, and I will see you in the next video. Bye.